this section is about random variables and probability distributions. And first of all, let's talk about what that is. So a random variable is a variable typically represented by x, and these are the definitions from the book, that has a single numerical value determined by chance for each outcome of a procedure. All right, so maybe that doesn't make sense, maybe it does, I'll talk about it anyway. A probability distribution, that's what this section is really about. Creating probability distributions is a description that gives the probability for each value of the random variable. It could be represented as a table, a formula, or graph. There are two types of random variables, discrete and continuous. And we kind of talked about discrete versus continuous before because we talked about discrete data values versus continuous. Discrete is, finite or countable, typically, whole numbers. And then continuous has, those decimals, anything. So it comes from, an infinite scale. Now, this may or may not make sense. So what I want to do is create a probability distribution with you. This is in the book, but regardless, I'm going to create it with you. So this is an example probability distribution in a table form. So I have two columns. One is my x, my random variable, and one is p of x, the probability of each random variable. This probability distribution is going to represent flipping a coin twice. Okay? So the procedure is flipping a coin twice, flip, flip. X, the random variable in this case, I want to know what the random variable represents always, but the random variable in this case represents the number of heads that I get when I flip a coin twice. So what are all the possible outcomes? So, well, first of all, X representing the number of heads, how many different heads can I get if I flip a coin twice? Well, I can flip it twice and get 0 heads, meaning tails and then tails, right? TT, tail, tail. I can get exactly 1 head, meaning I can go flip the coin, get a heads and then a tails, or flip the coin and get a tails and then a heads. Or I can get 2 heads, right? Heads and then heads. So these are all the possible outcomes, right? When I flip a coin twice, where the random variable, I'm determining the outcome based on the number of heads. So I can flip a coin twice, get 0 heads, tails, tails, get 1 head. Now obviously order matters. I can get heads first, then tails, or tails first, then heads. Or get 2 heads and then heads if I flip the coin twice, okay? So these are all the possible outcomes. Now, what are my random variables? Are they discrete or are they continuous? Well, they represent whole numbers. I can't represent a decimal amount of heads. So therefore, I'm going to say that they are discrete, correct? So I'm setting up my probability distribution for this particular procedure. It's in a table format. And now I have the total number, of heads. These are all the possible outcomes. So the first thing I want to do with a probability distribution, I need to define the procedure. I need to define what the random variable represents. If this represented something else, then I might have different outcomes. And then I'm going to actually calculate, in this case, the probability of each random variable. This is my probability distribution. It has to represent all possible outcomes and the probability of each possible outcome for a specific procedure. That is what a probability distribution is, a description that gives the probability for each value of a random variable for whatever situation. A random variable is a variable, typically represented by x, that has a single numerical value, in this case they're discrete, determined by chance, which this is, for each outcome of this procedure. So my procedure, flipping a coin twice, my random variables represent number of heads. Make sure you guys are muted. Okay. All right. Let's calculate the probabilities. Now we could do it for this case. If I were flipping the coin more than twice, it would be a lot more effort involved. The next section, binomial probability distribution, will help us with those calculations. But let's see if we could do these. So if I go and I flip a coin twice, let's start with the first outcome. What is the probability of getting a tails and then a tails? Well, I'll have a tails and then a tails. 2 events. What does that remind you of when I have more than one event? product, multiplication rule for probability. More than one event, I have to multiply. What is the probability of flipping the coin first and getting a tails? Well, what's the probability of flipping a coin and getting a tails? Well, how many total outcomes do I have? 2. And there's only, one tail out of 2 outcomes. Are these independent events or are they dependent? You know, is the probability of me getting a tails on the first flip affecting the probability of the second? I mean, it's not a cheating coin, right? They're independent events. So again, a half. So the product of these two, 1/4, represents the probability of flipping a coin twice and getting 0 heads, or tails and 10 tails. So 1/4 is also 0.25, okay? So that's my first case. I'm filling out my table. Let's do heads and then heads, because that's an easy calculation also. Only because of the situation, right? There are only 2 cases. If I flip a coin and get heads, it's the same probability as flipping a coin and getting tails. So getting heads and then heads, also 1/4. So 0.25, right? Also independent events. And what about this one? When you hear or, what does that remind you to do? Yes, addition. I need to add. The or is addition. I need to determine this case or plus this case. So the probability of flipping a coin twice and getting exactly 1 head with these different combinations, I have to consider the order that it happens. Well, now I have to do it separately. The probability of getting a heads and then a tails first, this one. Well, the probability of getting a heads, we said, was 1/2. And then the probability of getting a tails is also 1/2. So again, 1/4. But or plus tails and then heads, 1/2 and 1/2. So this is 1/4 plus 1/4. I'm running out of space. Or 0.25 plus 0.25, which is 0.5. So here's my probability distribution for this particular procedure. If I were flipping the coin 3 times, imagine all the different combinations that I can have in that case. Obviously, if I keep going, right, if I flip the coin 3 times or 4 times, this is going to be like a lot of cumbersome type of calculation. The next section, binomial probability distribution, helps us with that. But I want you to think about something. 2 requirements for a table, a graph, anything, a formula to be a probability distribution. The first requirement is, considering that probability is involved, the probability of any random variable has restrictions. All these values cannot be less than 0 or greater than 1. Right? I never have a probability that's negative. I never have a probability that's greater than 1. If you think about this, this is a probability distribution table. These represent all the possible outcomes, and these are the corresponding probabilities. What do you think the sum of this column has to be then? The sum of my probability column would have to be equal to 1 to represent 100% of my situation, right? So 2 requirements have to be met, right? The probabilities have to be between 0 and 1 inclusive. If they're 0, impossible events. If they're 1, well, then that's the only outcome. And the sum of the probabilities has to be equal to 1. So what is a probability distribution, right? A representation of a procedure, this is an example of one, which contains random variables, and each random variable represents every type of outcome for that specific procedure, in this case where it's defined to be numbers of heads, and the corresponding probability for each particular random variable for each particular outcome. So this column has to be equal to 1. That is what a probability distribution is, and that's what random variables are. This is a table form of a probability distribution. You're going to see graphs coming up in chapter 6. Not as many formulas in this class, but So let me stop there and ask if there are questions.
I have a question.
Okay.
When you wrote for the second column, the number, like the number column, add them, you add 1/2, like times 1/2 plus 1/2 times 1/2. You wrote 1/2 plus 1/4. How did that,
No, that's
as
supposed
a
to be.
decimal, equal 0.50? I understand it.
This is 1/4 plus 1/4. 1/4 plus 1/4.
1/8.
No. 2/4. 1/2.
2/4. Oh, geez. Okay.
Yeah, be careful.